The measures from the previous video can also be applied to group data. So let's revisit the example with the grades in statistics. So this is the data that I used to discuss central tendency measures, and now let's see how this set can be analyzed using the measures of variability. So to calculate the range, similar to individual data, we take the largest value and the smallest value. So in this data set, the largest value is the grade of 100 and the smallest grade is 10. So 100 minus 10 is 90. Midrange is estimated in the same way as for individual data, the largest value plus the smallest divided by 2. So the largest grade is 100, the smallest grade is 10. When we sum them and divide them by 2, we get that the mid-range is 55. We can also estimate the mean absolute deviation for group data. And as you can see, what we need to do is first we need to take the midpoint and subtract the mean value from it. After this, we take the absolute value of this difference and multiply it by the number of observations in each group. So, for example, for the first group, we know that the midpoint is right here is 22. So the average value was found to be 52. So 22 minus 52. And then we multiplied by the number of observations within this group, and the number of observations in this group is 5 students. And we do the same for the other 3 groups, and we get, after this, we divide this sum by 25, so the number of observations, the number of students, and we get that the mean absolute deviation for this group data is 17.6. To calculate the variance, what we need to do is also take the midpoint, subtract the mean value, but this time instead of taking the absolute value, we need to take this difference to the second power and then multiply it by the number of observations within each group, and after this everything is divided by the number of observations. So the midpoint in the first group is 22, the mean value was found to be 52, we square this difference and multiplied by 5, which is the number of students within the first group, and we do this for the other 3 groups. We sum these values and divide them by 25, which is the number of observations, so the number of students, and we get that the variance for this group data is 441.8. To get the value of standard deviation, similar to individual data, we just need to take the square root out of the variance. When we do this for this in group data, we get that standard deviation is equal to 21.02. Similar to individual data, we can also estimate the coefficient of variation for group data, and the formula is exactly the same. We take the standard deviation, we divide it by the mean value, and we multiply this ratio by 100%. So we get that for this sample, the coefficient of variation is 40.42%. And now let's have a look at skewness once again. We already had a look at these 3 graphs, and we know the skewness can be positive, it can be negative, and it can be normal. So in other words, no skewness. And we can also quantitatively assess this phenomena. So for example, we can estimate the coefficient of skewness, which is estimated as the ratio of the difference between mean value and mode divided by standard deviation, and this coefficient will always lie between the negative value of 1 and the positive value of 1. So if it is equal to 1, we have positively skewed data, and if we have a negative value, that means that we have a negatively skewed data. So the value of 0, which will mean that the data is normally distributed, so there is no skewness. In addition to the coefficient of skewness, we can also estimate just a general measure of skewness, and there are 2 formulas, one for individual data and another one is for group data. So if you look at the one for individual data, you can see that first of all we need to subtract the mean value from each individual value, take it to the power of 3 and sum the values, and then divide by the product of the number of observations and cubed standard deviation. As for group data, first we need to subtract the mean value from each individual midpoint, take this difference to the power of 3. After this, it needs to be multiplied by the number of observations within each group. After this, we sum those values and divide by number of observations and cubed standard deviation. So if you get the skewness is equal to 0, that means perfect symmetry, so normal distribution. Positive values indicate right skewness, whereas negative values of this measurement indicate left skewness.